Are you sure? Because I cannot see any. Now, okay, now I see it.
Now you see it. Okay.
Okay, let's start. A small disclaimer before we start. Today I'm going to implement validation with you and consider it in context of functional programming and how we can use one of the concepts from functional programming called monad. And if any questions, you can guys interrupt me and ask. For today, I'm going to use effect TS library, and the things I'm going to use is just very small part of it, because the library itself it's very big and gives a lot of possibilities to do things in, I guess, any JavaScript environment on frontend or Node.js. So yeah, if you are interested in it, you can check it. But for today, we're going to use just a couple of helpers, and that's it. Let me share my screen. Can you see it?
Yes.
Yes.
Okay.
Yes, you see it.
I will turn off my camera just in case Teams starts lagging. I hope it will be fine, but if any lags or any issues, just let me know. Yeah,
you have a lot of tabs in your browser.
Yeah, it should not be an issue. Yeah, we want to implement validation, and of course, any validation starts with conditions or some checks that we want to perform over data. So let's start with a simple thing. Function validate that will receive some value of unknown type or generic type, and then it will do some check. For now, it can be any, because we don't care. Then if something is wrong, it will return error message. Otherwise, it will be valid value. By the way, one more thing for guys who work with me on Rebels project, it's the same pattern. So if it was a little bit difficult to understand validation on that project, if you used it somewhere else, today you will get explanation on it. So I hope it will be much better to understand what's going on and motivation for this. Let's go back to the validate function. And if we analyze it, it's very simple, but we already have some problems. The first problem is that our check is hard-coded in that function. And if we want to perform any other checks over data, we cannot do it. So we can teach this function how to perform any other checks. It should be a function that would do something. But, now let's just add it. This function, of course, receives the same value and then returns Boolean. So we can do this. And now we are able to provide some validators or checks. Let's say we want to check if string is empty. But it should not be empty. So if it's not empty, the function goes here. Then we provide some value. the function is called here. So if it's not, oh, let me think. Yeah, it should be empty. If it's empty,
Yeah.
then we Thomas is here.
Hey, sorry
Then
for
it's,
running crazy late.
Yeah, no problem. Just a small introduction for you. We're going to implement validation using some functional programming stuff. That should be enough. And I just created a simple validate function that receives a function that will perform check, and then it will receive a value, combine them together. If it's wrong, return error, otherwise return error. That's it. Yeah, now it works, and it's even better because we can do different validations. And this thing you see here, if there is a function that receives some value and returns Boolean, it's called predicate. So now it's named function instead of just f, which is better. And we even can create a type of predicate, which also receives some generic value. And returns Boolean. Then we can use it instead of this. Boom, works. The next step. Now we can fix it here. The next step is a value that we return from validate function, because now the problem is that error is string type, and value we provide here is also string type. So as a result, we have string, and we cannot understand, is it from type level? Is it error here, or it's a value here? So it's better to separate these two things, and we can create objects with a tag discriminant field. It can be left or invalid, and field error type might be string. And here we can say the same tag, but right. I will explain left and right naming a little bit later. And value is t. Now, of course, we have error here because we need to create those objects. I will not do it here because anyway I need to change it. So left and right comes from functional programming. Right now I will guess because I don't know explanation, but I think it's just because we have some entity return value, and it can be in two states. It can be invalid and valid. But imagine that besides the validate function, we can have different functions, and they also can be into different states. And to be abstract from what exactly the function is it validation or something else? We want to have this tag more common to use, because we can say it's invalid, but for something else, this approach will not work. So instead of putting this word to some context of function, we just say in general, it's left branch or correct branch or right branch. Sorry, left is incorrect and right is correct. So that's why I think they call it left and right, but I'm just guessing, I don't know for sure. So Yes, now we have here this object with error or this object with value. So it's very simple to get the value from those just by checking if it's left. Then we have access to error, otherwise to the value itself. So it's fine. And now it starting to be more interesting because in functional programming we have, or they have, a type class called either. Now let me just rewrite it a little bit. Let's imagine we have either type, which is just combination of these two. And here we have two generic arguments, one for error, another one for value. And I'm going to just use that type from library. For Thomas, library is effect.ts. It gives you a lot of things, how you can do stuff in functional way. And today we're going to use only either type class, but there are a lot more besides that. So yeah, we are going to use this type, and if I replace it here, it will be the same. Only the difference that instead of tag they have underscore tag, and instead of error they have left. And for right they have the same, but instead of left it's right. And value should be error. Okay, I cannot get what's wrong, but probably we need to use, this is the way how we can create a left value in our case, but probably should not work if we use either from the library. And to create left and right values, we need to use some constructors, because if we go to either type, we will see that it is a combination of left and right, and they are just classes. So to create instance of one of them, we need to use constructor. Let's do this. It's again from library, and they called left. And to left, you need to provide error message. Yeah, now it's correct. And for this one, let's make it correct as well. Boom. Now it's fine. And if you see this type is the same we have implemented locally. I mean the same because the left inside has the same structure, tag and error, or left, and this also have the same structure, tag and right. We have here error and value, but it doesn't matter, we can do this. So I hope it's clear. I'm going to comment this, we don't need it anymore. And to get value manually from either type, you can perform the same validation. The same, check. If it's left, you have access to error. If it's right, to value. Now, Another problem of this function that this function probably don't need to know about how to create valid and invalid values, and we can be abstract from it here, and we can just move it to another function, which is validator. So we can create type validator that is almost the same that the predicate, only the difference is that it will return either error or some value. And to implement it, we can do this. We're going to reuse the same naming, is empty validator. The string here. What it does, it just do this thing, but it reuses predicate that is okay. Yeah, we just have to reuse this predicate here. So it's validator, and then instead of passing predicate to a validate function, we can pass validator and code here. And we need to change type, and instead of passing validate, predicate, we need to pass right validator. Then it's almost the same, and here we don't need to do anything, we can just return value as it is. Done. So this way gives you possibility to create different predicates and validators. They a little bit interconnected between each other if we consider the same predicate and validator, and it should be this way, it's fine. And also having predicate, you can create automatically validator just by passing it to another function called from predicate. It's again a helper from either. It as you can see here, you need to provide a requirement which is almost the same that predicate. We can even check that it works with both with refinement and with predicates. So you can do this, and then you need to provide another function like what to do if it fails. So if it fails, you need to create an error, and that's it. This and this are the same. We just simplified putting error and value to expected context. If it's error, it's left. If it's value, it's right. And this function does it for us. So I will comment it. I will use this approach just to be a little bit more explicit, but keep in mind that it's also possible. Then another problem of the function, if we consider it, it basically doesn't do anything, but what we can expect that, okay, if it validates over if it uses only one validator, I want to provide more validators. I want to check if string is empty, if it's alphabetical only, etc., etc. So my expectation would be it should be possible to provide multiple validators. So let's just change it. Because we provide multiple validators, then this should be an array. And you can imagine if there are multiple validators, they can all fail. It means that we have multiple errors. So now it can be errors or just valid value. Now we need to re-implement our function a little bit. So what I want to do, I want it to perform all validators over value we have. If all succeed, we return value without any changes. And if at least one of them is failed, we need to return error. Or of course, if multiple failed, we return multiple errors. Let's just check it. So this is variable of all validators performed on a value. We can just map and call it directly here. Then we have either error or value, everything, I mean the whole type inside error. But we need to have this error for errors instead of the whole type. And we can easily do it. Let's check if every item is right. It means there is no errors at all. We can just return a value that is wrapped to right constructor. So we are basically doing this, but for array values, not for only one. Boom. Otherwise, we want to filter errors, and then now we have array of errors, and instead of array, we want to have I forgot. Yeah. Right now it's array of errors, but we need to have failed value of array of errors. So this array should be here inside. Yeah, so we can just reduce it. Here errors, here invalid value. Then we can just combine them together. And the start point will be empty array. But now it's any type because of TypeScript. It cannot infer type of this array because it's just an empty array. We can help a little bit. Say this. And yeah, now we can see error, and the error is that this invalid type. It is left instance of either with error inside, but it should be just error. So we can pull left value from it, or error. So should be enough. Yeah, and we need to wrap it to left instance because we return invalid value in this case. And invalid value itself is just array of errors. Now it's done, and we can, as you can see from type, it works. You can provide multiple validators. If any error, they will be combined. If no errors, we will see validated value. I mean the source value that we provided. Let's try to use it. I'm going to create input. And state. And we need to get value from that input. It should work. And then if I want to validate it, I can just do this. I'm going to use pipe function. For those who don't know what pipe is, imagine we have multiple functions. What we usually do is we call function f, then function t inside, then g inside, etc., etc. Then we provide some value, and you have this nested functions called. And then with pipe, you can make it a little bit easier to read. You provide value, and then one by one, just like unwrapping these functions, you can pass them to that pipe, and they will be called from left to right. So it's the same. Okay, our start value is value from input. Then we need to validate. Probably I didn't export it. Yes. And to use validate function, we need to provide some validators. Now, from type system, it seems fine. We have either with error or value. And then to render it, well, yeah, I didn't explain, but when I was creating either manually, having those two objects with left and right tags, it was just simple way how we can mark our data, error or data with some knowledge if it's error or value. But when I used either type class from the library, now it creates instances of these classes, and these classes they implement modded interface, which means that if I want to work over value inside this monad, I have specific methods that I can perform or use. So to unwrap this either, instead of manually checking if it's left or right, I can just use a method called fold. And this method will enforce you to explicitly unwrap every possible situation. And in our case, in either, we have two possible cases. The first one is left, the second one is right. So here we need to provide two functions. In the first one, we have access to error. In the second one, to value that is validated. Then here we can implement some markups. And say if any errors we're going to render them. I need to provide key, but I will ignore it for now. It's not important. So errors should be rendered. Then we have value. So we're going to render it just, no, okay, we are not going to render it. We will say no errors. This is unused. Then if we check type, it's JSX element, it's fine. So let's just render it. No errors, but if it's empty, it doesn't work. I don't know why. Let's check. Probably something wrong with the validator. Now let's analyze a little bit. So we pass empty function to validate. That is already attached with a validator. So
Probably the problem is that the error is empty string.
Yeah. Correct. Yes, now we have error. Thank you. And now we have almost 20 minutes left. And I just think what else to explain, because well, basically we implemented validation, and right now I only want to show different ways and what you can do with either data, either type class, because if we have our own things implemented that I did here, it doesn't give us anything. It only helps us to understand what value we return in the we have in the end. But either gives you a lot of useful things, and not to create overhead. I want to play with it and maybe just to show you how to use map method and chain. And for example, yeah, let's imagine that we are expecting numbers here, or maybe we want to let user input card number, bank card number, which includes different letters and numbers, and we want to validate if it has a valid numeric value. Then we want to extract it from the string and just to do something. I even don't know what, but yeah, let's just imagine that it's the case, because the problem is right now that validate function cannot receive validators that can return another value that we provided, because now we can validate strings only, but you can say, what if I know that there is number inside and I want to validate that number? How can I do it? Because the whole solution is declarative. It's up to you. It gives you a way to do it, but it's on your side. So what we can do, let's say if this validation is correct, we can yeah, we need to provide. I didn't want to write one more validator because I'm too lazy, but probably I have to. So what I want to create another validator. Now let's imagine that this is what we expect. Left part letters, right part numbers. And right now I want to validate that after 4 letters I have some number. And this is my validation for this function. So I want to know if right part is numeric. Because I provide a string, I need to extract a value. Let's use substring. So I expect starting from index number 4 to the end of the, or what? Length. Okay, I expect 4 digits. Then I need to make it number. Yeah, this can be a little bit unsafe, but you can do it in any way you want. If it's not enough safe, you can implement another way. It's not part of presentation. Then we need to validate that value is not empty. By the way, I can use this. Because we implemented everything separate and these are just small parts of our big application, we can reuse everything if it's useful in any way. So it's not empty, and then this is not none, because you can write some things that cannot be converted to number. It will be none instead of number. And then who can help me to count? Okay, I need to remove this. Bum. Let's see how it works, even if it works. Something is wrong. Let's analyze.
I think there should be if not is empty. Yeah.
But something is still wrong. Maybe when I want to get this value. Nope.
If you go back and so if not is empty and is none, right?
Yes, because we need to check failed branch That's why we want to have
Yeah.
Invalid statuses of these checks. No errors, dynamic. Nice. Now it works. Thank you. Okay, and then we want to, in the end, to have this number, let's say, in a different div. So what we can do here, important part here that when you have, if we had this way implemented of either, when it only gives us information if it's left or right and nothing else, we had to just in this function have if statement and say if are validated and then tag left or right, then we can have access to the value, and then we can extract number here, save it to maybe state, maybe to another variable, and then render it. And every time you want to transform value inside that validation somehow, you just have to have these checks. But what monad interface gives us, it gives us a map method, and we can be just totally abstract from implementation, and we don't care when I call this, what state of my computation, is it already failed or not? I don't know. It's just functions that will be called one by one, and when I work with map, I'm just abstract from current status because it's not interesting. I know that I can just provide a function that would do some work for me. So I can say here, I will receive value after it is validated. So on this line, we have either type error or string. And when you call map, it just goes inside of this either and allows you to work and do anything with value. That's why I don't need to do any checks. They are done under the hood in map. So if I have value, I want to extract this. Of course, I can move it as a separate function, reuse it here and there, but yeah, for now, let's just copy paste. It's done. Instead of no errors, let's render value that we have. Not instead of, but in addition. Yeah. It works somehow, which is cool. But I don't know where this null comes from, probably because here I cannot, when I'm extracting the right part, it's just an empty string. So the value is still here and it's null. And what's important here, that if you perform any unsafe things here, you can validate them and the error will be lifted to the top level and you can catch it here. Let's try it. I will not use any validators here. I will just do very unsafe stuff just to show you that it's possible. But imagine that right now I'm validating this and say if it fails for some reason, or I can even validate this value. And here I can say if it's a valid number and this is already different validation, then perform it or provide value further. But now I just want to fail it to show what happens. So to fail it, I can use try catch block. It's also from either, which means that it will do the normal try catch. If it failed, then the error will be passed further. If it succeeds, valid value will be passed as well. So this is the function that should be failed. Let's say and then another argument is what to do if computation I expect this one, if it failed. I want to, or not, let me check. Yes, on error. Now it's incorrect because of this. Oh, yeah, this is really unexpected gag. To be honest, I don't know what happened. Probably I'm trying to render something that shouldn't be rendered. Let me think.
Looks like the value is an object now. Does try catch wrap them in left or right?
Nope. Oh, yeah, it should, because here I do anything and I should not return anything here. And then on error, I return error and it automatically has to wrap it to either to left and right. It's interesting. So this is the error and it is expected. Let's see here. Yes, it's the error we expect, and it fails on the second step. I mean, not fails, but this is what we see there. Then
is it because the error object is the left, so that's the correct object, right? So in the fold, you go into the value directive, which renders no errors value, but value is an error object. So maybe it's trying to render it as an as a React element as value on line 39.
But it should go to left branch because.
Oh,
Oops.
you're right. Never mind.
Yeah. Because we receive left branch here. That means that this should be called. Maybe I know. Oops. Yeah. No errors, but what we wanted to do, I already forgot. We validate and then we map. It should fail. We need to probably return it here. Now it's still error. Okay, we ran out of time. It's very interesting when I, for now I just cannot see it because I'm too focused on things I'm trying to keep in mind, not to forget to tell you, but I will find out the problem and I will post in chat somewhere. Probably it's very simple, but I need just a couple of minutes more to think about it. Yeah, just a couple of words in the end. Even that this is failed, but it will be very easy to find the problem when I just say and I mean when I see it and think step by step what's going on here, because we don't have a lot of actions and everything is just a small function, so it's very easy to predict what happens. But yeah, for now it's just I need more time. So let's analyze what we have done. In our small application, we can create a bunch of predicates. By the way, everything is, as I said, simple functions, so it's very easy to cover them with unit tests if you want. So we have predicates. Then based on those predicates, we can create some validators. Everything is customizable, so you can have different checks that you want. Also, you can provide an error dynamically, and based on different situations, maybe you want this validator to have different errors based on different context. So it's also possible that this error will be dynamically provided. Then everything goes to validate function that just performs validations on the value you provided. So everything is type safe. Besides something I did wrong, maybe something with throwing. I'm not sure. Well, yeah, it's also possible in this function to implement it into different ways. One way we've done here when we start all validations in parallel and then we receive errors. Another way you can do it you can fail it fast, and I mean if there is at least one error, the rest validators will not be called, so we will have just one error here. Yeah, and then how to use it? Just grab some value, provide to validate function with validators, and then we can forget this for a moment. And then your value will be in two states, valid or invalid, and you could do whatever you want with both of these statuses. It is very explicit. You never forget to handle error because fault method will enforce you to do it. And yeah, I didn't have time to explain in details, but you have either map and either chain, which are almost the same. and they help you to be abstract from current state and just transform value somehow. And chain does the same, but only the difference that if your end result is also either, it will collapse two contexts of either in one. Oh, yeah, that's it for today. If you have any questions, please ask.
I've got one question. So this pattern maps nicely to the UX situations where you need to output multiple errors at the same time, right? Like you do here, you map over all the errors and say, if you have a password and you need to have a letter, or you need to have a big letter, or you need to have a number in there, or you need to have a special character. And you see a lot in the UI that they're all out there at once. But there are situations where you need to check something first before you get to the next kind of validation. For example, if you have a date, you need to enter the date, and then if this date is before or after the certain point of time, then you give another error. So how would you implement this second pattern with this approach?
I think there are three approaches. The one is to re-implement this function to be a little bit smarter and to be able to work in these two ways. Let's say we have some validators dependent on other. So if they valid, do other validators. If they invalid, just return value. I already said it that we can implement it in any way. It can be this function, or you can create another one just not to combine both of these approaches, so you can separate responsibility. Another thing, maybe you can structure errors somehow, and when you map them, you can just filter. But yeah, I'm not sure if it's possible. I need to think about it. Only thing we need to understand if it's a responsibility of validate function, and it should be smart enough to work in this way. And we are fine if it will be a little bit more complex, or it is responsibility of something else. But I think, yeah, we can just re-implement this function, and it can work in both ways, depending on the case.
Thank you.
Anything else? Okay, probably no more questions. I hope it will be. It was interesting, at least a little bit. Yeah, thank you all. That's it. Bye bye.
Thank you. Thanks for having us.
Yeah, thank you, Alex.
Enjoy the weekend.
You too.
Thank you. Have a good weekend.
Thanks a lot, man. It was really interesting.